everybody, welcome back, and we are going to begin 4.2 graphing rational functions. So this is day 2. We're going to continue to identify points of concurrency, or not concurrency, points of discontinuity, and we're going to continue to graph the rational function after we put it all together. Okay, so here we have this function right here, and we're going to identify our holes, vertical asymptotes, horizontal asymptotes, our x-intercepts, our y-intercepts, and then put it all together in our graph. All right. So first thing we want to do is factor this guy. Okay, so we're going to factor this into x minus 2 over factors of negative 6 add up to positive 1 will give me x plus 3, x minus 2. Right? So then, of course, our x minus 2's, these factors here will cancel each other out. And this will leave us with just our 1 over x plus 3. And that will be our final rational function. Okay? So we canceled out, since we canceled out the x minus 2 factors, that's a common factor, that will become a whole. At x equals, I wanted to get that, the red, sorry about that. This will become x equals 2, is where my whole will be, right? Then I also have a leftover factor here, that all said and done, so that will be a vertical asymptote at x equals negative 3. Okay, our horizontal asymptotes come back over here. Our power on the bottom is bigger than our power on the top. And so that means our horizontal asymptote is going to be y equals 0. In that case, our x-intercept is found. We'll kind of talk about this as we graph it. But if we plug in all of our zeros for x, that 0 will go away, go away, go away. And all we'll be left with is a negative 2 divided by negative 6, which will be a positive 1/3. So this will be a 1/3, 0, right? And I'll talk about our y-intercept here in just a minute. So let's first of all graph all of these guys. So first of all, we have our vertical asymptote. We'll go ahead and make these green, since I put them in green there. So at negative 3, so I have a vertical asymptote here at x equals negative 3. And please, in your homework, be sure that you have straight lines, okay? No, cucky lines and so forth. Make sure you use a ruler and make sure that they're straight, okay? So there are my asymptotes. Now this graph might look a little bit familiar from the ones we graphed last time, where we had our left and right shifts, and then over here would be our up and down shifts. And notice that over here we don't have any up and down shifts, just plus 0. So that's why how we end up with our x-axis as our asymptote. This one right here, it shifts left 3, boom, 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 left 3. And if you recall from that kind of origin spot, this over 1 up 1 and over 1 down 1 was kind of our mother function area, right? Okay. And so from here, you can kind of think, if I plug in like a huge number, 100, 1 over 103 is going to give us a tiny, tiny number, right? So it'd be like 103 over a little bit. Or if I plug in 10, it'd be 1 over 10 and 1 over 13, 113. You got this little tiny, tiny dot right there. I don't know what happened there. I get these little crazy dots sometimes, just every once in a while, right there. Okay, so then if I plug in the number really close to this axis here, so let's say I plug in a negative 2.5 or whatever, that's going to become a positive number. It's going to go up higher the closer I get to that axis. It's going to come down. If you remember our parent functions we talked about, it's going to come down through here and go this direction. This one's going to come down over here, go through that another point here, and come this direction here. Okay. Now, how do we deal with this hole? We have a hole at x equals 2. So how I deal with that guy is I'm going to come over where x is 2, on the axis is 2. First of all, I got to get my eraser. So go over where x is 2. I'm going to go up to the graph and just just erase it a little bit. Okay. And then I'm going to grab my pencil here. I'm just going to put a hole in my graph. Boom, done. Okay, and that's where my hole is. And that is my graph. Okay. Okay, so down here it says kind of for a graph also choose values on extreme ends of the asymptote or away from the asymptote. So like I said, if we pick the value way away from the asymptote, like 100, that would kind of give us an idea of what my behavior is doing. So like 1 over 100 is going to be a tiny, tiny number, right? And then over here, as I get closer to my asymptote, it's going to become a bigger and bigger number. So I know the end is going to be coming from way up here down to a little tiny one down here. And we can do the same thing on both ends here. I'm going to kind of play with that here on our next graph a little bit more. Okay, so for this one here, we have no holes in this particular equation. There's no common factors in the numerator and denominator, so we just are going to write none. And then for this guy here, vertical asymptotes, we have one at x equals -2. And for our horizontal asymptotes, we have even powers. So it's going to be just our leading coefficients divided. So 1 divided by 1 gives me y equals 1. And so now we can start to put together our graph there. Now we're going to grab our dashed line here. We have a vertical asymptote at x equals -2. So we'll just grab that guy. Our horizontal one this time is going to be y equals 1. So we'll just grab that one. Go on here. We don't have any holes this time. So now, since this is kind of weird, so this doesn't look like the typical parent function graph that we usually graph. So I'm going to go ahead and make a table. And sometimes making a table can help us figure out what our graph is doing on our ends. Okay. And so what I like to do is kind of pick the right-hand side and then kind of the left-hand side. So if I look at the right-hand side, if I pick the value of -1, so like right here, because you know how sometimes I go over 1, up 1, and maybe that will be where it's at. Maybe it won't. But if I put -1 in, -1 plus 5 is 4. -1 plus 2 is 1. So 4 over 1 is 4. Okay. So -1, 1, 2, 3, 4. So you notice this time is a little bit of a stretch to it. Okay. So I'll go ahead and graph this guy. -1, 4. Right. So what happens if I plug in 0? So this is going to be like my y-intercept here. It'd be just 0 over 0, which is 5 over 2, which is 2.5. Okay. And then how about if I just plug in 1? If I plug in 1, I get 6 over 3, which is 2. Okay. So this is like my right-hand side of my graph right here. Okay. On the right-hand side of the asymptote. So I have 0, 2.5. And then I have 1, 2 right here. So you kind of see it's kind of scooping down right here. So I know my graph behavior is going to go something like this. Okay. Now we can do the left-hand side of our graph. Okay. If I put the left-hand side of my graph, if I plug in -3, which is just on the other side of my asymptote, so I plug in a value of x of -3. -3 plus 5 is 2. -3 plus 2 is -1. So 2 over -1 is going to give me a -2, right? If I plug in -4, the next number over, -4 plus 5 is 1. -4 plus 2 is -2, right? And so that gives me a -1/2. If I plug in a -5, what happens here? -5 plus 5 is 0, and 0 divided by anything gives me a 0. So that's going to be our y-intercept, okay? And that's how we find our y-intercepts. Is even if I had another equation, I wanted to find my y-intercept, it's when my x's are 0, right? And so I just plug in 0 for my x's, right? So -3, -2 here. I have -4, -1/2. Then I have -5, 0. And so you can kind of see my graph is going something like this, kind of climbing close to this. So it's on the right-hand side up the left-hand side. No holes, so we are done with that graph. Okay. Okay, let's move on. This is a little more complicated, simply because I have multiple asymptotes. Okay, so let's look at our, we don't have any holes, right? So our holes, we have none. For our vertical asymptotes, we have x equals -3. We have x equals 2. Okay. For our horizontal asymptotes, we have, now let's be careful here because it's hard to tell what the powers are right here. This will multiply to be, we have x minus 1. This is going to be x squared. And then -2x plus 3x is plus x, and then -6. Now we can tell what our power is going to be. So my bottom is bigger than my top. So that means that y equals 0 is going to be my horizontal asymptote. Okay. So if we put these all together, I put in my x equals -3 right here. And I'm going to put in my x equals 2 right here. And my y equals 0 right here. Now what this does, you'll notice we don't have just two sides of our graph. Now we have two asymptotes. So we have actually 3 different chunks of our graph. Okay. This is where it gets a little bit trickier, and this is where table of values will come in handy. But to know how to do your table of values is going to be kind of the trick, okay? And this is where I was saying how to pick values on extreme ends of your asymptotes, okay? So I'm going to go like this, and I'm going to say we're going to go on the right-hand side of this asymptote over here, the far right, And I'm going to go just on the other side of this asymptote. So I'm going to pick 2.1. I don't want to pick 3. I'm going to go just 2.1 and see what happens if I put in 2.1. And I'm actually going to plug into this guy. I'm going to put my values into this guy, because that's going to be sometimes easier. Sometimes it's easier, sometimes it's harder, whatever. Okay, so if I plug that 2.1 in for there, I end up getting 2.1 actually back out. Okay. If I plug in 10, so now I'm going to pick a value that's far away from my asymptote over here. So if I plug in, say, 10, I'm going to get 0.08. 0.08. So this right here, this is going to be my right-hand side. Okay. So if I go 2.1, I'm going to get 2.1 back. If I go 10, I'm going to get a 0.08. So I know that it looks like it's going to be coming from up high, down low. Okay. So that's how we kind of tell our behaviors of our graph. It's going to come from up high, down low here. Okay. And so now let's go ahead. Let's do this middle section. The middle section can be tricky. So I'm going to actually go ahead and I'm going to do a different color here. So if I put in just on the other side of my asymptote here, so 1.9. Okay, so when we plug in 1.9 just on the other side of the asymptote, so kind of close to it without going over. Okay, if I plug that in, I'm going to get negative 1.8. I'm not going to go through all the evaluation of how I get 1.8, negative 1.8. I'm going to let you guys go ahead and substitute 1.9 in there and evaluate. Those are all just evaluations. Right now, I'm just going to kind of give you the table. Okay, if I plug in negative 2.9, I end up getting out, and so negative 2.9 because it's close to this asymptote. So I plug in a 1.9 and a negative 2.9. So the one's close to the asymptotes. Okay, that gives me a 7.9. Okay, so here's what it tells me. If I go 1.9, it's going to give me a negative 1.8. So notice that that's below my horizontal asymptote, right? Get away from that. Right? Oh my goodness. Every time. Negative 1.8 right here. Okay. Negative 2.9, however, goes above my asymptote to 7.9. Right? Well, what is my y-intercept? If I plug in 0, right, 0 for x, 0 for x, 0 for x, I get negative 1 over negative 6, which is a positive 1/6. So it's just like barely right here. Okay. Gracious. Barely right here, negative 1/6. So my graph comes from up high, it kind of bends over, and then goes down low. So it's kind of like a cubic looking function. Okay. And that's my middle part of my graph. All right. Now for my, let me go back over here. This is my middle part of my graph. Let me just go middle. Okay. Now for my other part of my graph, my left-hand side of my graph, I'm going to, again, pick a number that's really close, just barely on the other side here. So negative 2.1. Okay. So negative 2.1. If I plug that in there, sorry, negative 3.1. If I plug that in there, I'm going to get out a negative 8.0. Negative 8.0. Oh, wise. Negative 8.0. Okay. And then if I go way far away from that asymptote over here somewhere, if I just pick a like negative 10, you can pick a negative 100 if you want to, I get negative 0.13. Negative 0.13. Okay. So I get negative 3.1, I'm going to get negative 8 down here. If I get way out here, I'm going to get negative 0.13. So I'm going from down below over to here, right? So down below here, up to over here. Oh, that was not a very good graph. Come on, I can do better than that. Down from over here, up over here. That's a little bit better. Still not perfect. Okay, and so that's how you put those graphs together. There's no holes there, right? Sometimes these ones in the middle will make a U up here or down here. Sometimes you'll have both of these be up here and then have this one be upside down here. So there's really no, you can't just assume what shape the graph will take. That's why table of values, and then just pick numbers that are far away from my asymptote, close to my asymptote for the x values to find out what my n's are doing, close to my asymptotes, and sometimes in the middle here, and then close to my asymptote, far away from my asymptote to evaluate in my table, and that will help you see what the n's are doing. And you can always find also your x-intercept or your y-intercept. Sometimes your x-intercept. Here, I can't find my x-intercept because it's an asymptote. Okay? Okay, next up, let's do one more here. Let's go ahead and factor this guy. We have y equals x minus 3 over x minus 3 times x plus 2. I feel like we've already done this one, but I don't know. I could be wrong. So then this one cancels out right here. So we have a hole there. And we're left with just the rational function of y equals 1 over x plus 2. Now you hopefully can, recognize this. If I had, from last week, our shifts, this means it shifts nowhere up and it shifts left 2. And so without even identifying where my asymptotes are, I can actually just graph that guy. So that's another way you can do it, is by saying, hey, I can just go ahead and graph this. I have a shift left 2, so I'm going to shift this guy left 2. I don't shift anywhere up and down, so it stays right here on my y-axis, or my x-axis, excuse me. But I do, by the way, have a hole, right? I have a hole. I'm going to have to graph. And that's going to be at x equals 3. Okay, but I do remember that my parent function is going to be, kind of something like this. It's going to go from up here to down below. And it's going to go from over here down below. And then in order to put that hole in my graph, I'm going to go over here where x equals 3, come up to my graph where it meets it, erase it, and then come back over here and put a hole in my graph. And there we go. Okay, and that is how you graph. So I'm going to give you a worksheet in Google Classroom. This is kind of a concept summary and kind of talks all about the horizontal asymptotes, vertical asymptotes, kind of the algebra behind it, and then just kind of how to graph it. Okay, and then you have a worksheet in Google Classroom. I expect straight lines on your graph. I want you to label your asymptotes and holes. Take pride in your graphs and make them make them look good. You don't have 20 of them, you only have a couple of them, so you can take time and make them good, okay? And I'll see you all in the next Zoom. Thanks so much, bye-bye.